A freshly brewed cup of coffee has temperature 95 degrees, is placed in a room of 20 degrees Celsius. When its temperature reaches 90 degrees Celsius, it is cooling at a rate of 1 degree Celsius per minute. When does this occur? And so the question is asking for the time. And in this case, the unit of time is in minute. And so when? To answer that question, we will use the Newton's law of cooling, which states that T equals the ambient or the surrounding temperature plus T naught minus Ts, which is the difference in the initial temperature and the surrounding temperature, e to the negative kT, where k is the continuous rate. This is the temperature as a function of time. So this is T of the little t. The capital T represents the temperature in degrees Celsius, and the little t represents the time in minute. Next, we were told that when the temperature is 70 degrees Celsius, it is cooling at the rate of 1 degree Celsius per minute. And so that is the derivative because it is cooling at the rate. And so what we are told is that the derivative, or dt over dt, the moment when the temperature is 70 degrees Celsius, is 1 degree Celsius per minute. That's the information was given. And so to use this information, we would need to find the derivative. But first, let's see if we can plug in anything. The surrounding or the ambient temperature is 20 because the room temperature is 20 degrees Celsius. We know that the initial temperature of the coffee is 95. And again, the surrounding temperature is 20. E to the negative, we don't know the parameter k yet, and t is the variable for now. And so T of t is 20 plus 75, e to the negative kt. And again, we don't know the continuous rate k yet, but we're hoping to find out after we take the derivative. And so t prime or dt equals, there are two terms here. The derivative of 20 is 0, and the derivative of 75 times e to the negative kt is 75 e to the negative kt, and we still need to use the chain rule. The derivative of negative kt is negative k. And so the derivative is negative 75k e to the negative kt. And so how does it gonna help us? We need to find k so that we can find t, and we need to take the derivative because if we were to plug in 70 into the temperature, then we still have k in the equation. And so how do we use 70 degrees Celsius? On the one hand, if we plug 70 into the output or the temperature, we will get 20 plus 75 e to the negative k, and we don't know what t is because we're looking for the time. On the other hand, if we plugged in the derivative negative 1 because this is cooling, negative 1 equals, we'll get negative 75k e to the negative kt. And so this is a system of equation in two unknowns. We will be able to find k this way. First, we simplify the first equation by subtracting 20 to both sides of the equation. And so we'll get 50 equals 75 e to the negative kt. The second equation is that 1 equals 75k times e to the negative kt. And with any exponential model, we set up the ratio 1 over 50 equals 75k e to the negative kt over 75 e to the negative kt. The reason why we set the second equation on top is because of an extra factor k. And so e to the negative kt canceled out, and 75 canceled out 75, and so we end up with k equals 1 over 50, and so k is 0.02. Once we found k, we have 1 equals 75, k is 0.02, e to the negative 0.02 t, and that is where we will find our t. This is 1 over 1.5, because 75 times 0.02 is 1.5, equals e to the negative 0.02 t. We ln both sides of the equation. Ln of 1 over 1.5 equals ln of e to the negative 0.02 t. And again, the reason why we want to ln both sides of the equation is because we want to get t to the front of ln. And so ln of 1 over 1.5 equals negative 0.02 t ln of e, but ln of e is 1. And so t equals ln of 1 over 1.5 over negative 0.02, and this will give a 20.27. And so after 20 minutes, the temperature will reach 70 degrees Celsius, and the coffee is cooling at the rate of 1 degrees per minute. How do we know that this is the correct answer? We can plug all of these back into the Newton's law of cooling. If we were to plug k equals 0.02 into this equation, and then we plug t equal 20.27, we will get 70 degrees Celsius. And also, if we plug 20.27 into the derivative, we will see that we'll get roughly -1.